Hello everyone. In this presentation video, you will learn how to design concrete pipes using a free design software called PipePac. The PipePac software will help you find the pipe strength or the load bearing capacity required for your project. So before I show you how the software works, I want to talk about the Indirect Design Method for concrete pipes. This is the same design method that the software uses to find its results. So just to give you a little bit of a background, in the 1930s, the classic theory of air loads on buried concrete pipe was developed for trench and embankment conditions by Marsden. He also developed the 3H bearing test as a way to evaluate the strength of rigid pipe. In 1933, Standard presented three bedding configurations and the concept of bedding factor to relate to the supporting strength of buried pipe to the strength obtained in the 3H bearing test was introduced. In the 1970s, the American Concrete Pipe Association created a comprehensive fine element computer program called SPIDA, or Soil Pipe Interaction Design and Analysis. So since the 1980s, SPIDA has been used in a variety of studies, and through the consultations with engineers, we were able to develop new standard installations that are used nowadays. So the Indirect Design Method is the comparison of the structural strength of the pipe found in the 3H bearing test with the field strength when the pipe is buried. So the first step in your design is going to be to find how the pipe is going to be installed. This is because depending on the insulation type, the pipe will be subject to different loads. So for example, if you are installing your pipe in a trench conditions, the loads are going to be different than the ones on an embankment or positive projection. Additionally, the pipe will withstand higher loads if you're installing in a trenchless installation or a tunnel installation. So for example, in a trench condition, we're going to have a narrow excavation. That means that my native material will be close to the pipe and it will play a role in the load distribution. So the dead load will be the column of soil or backfill right on top of the pipe times a load coefficient. You can see that on the equations on the right. So that means that when my soil settles, we are creating a frictional force going upwards that reduces the amount of load that the pipe is going to carry. This load distribution is going to be different in an embankment condition because the pipe carries the full load of the backfill above, plus additional loads as a result of the frictional forces, making the embankment installation a more conservative approach. So the second step is going to be determining your loads. So your dead load, your live load, and any extra loads. So our dead loads, we already saw the equations to how to calculate them. So with your live load, what you need to know if you are going to design a highway, an airport, or a railroad. You will have different live loads per each. And lastly, your surcharge loads. So your surcharge loads are going to be construction or post-construction dead loads directly over the pipe. So for example, an adjacent building or a retaining wall will be a surcharge load that you need to apply in your design. So for your track load in Canada, we have the Canadian Highway Bridge Design Code CLW load. So it is required to design your highways as a CL 625 unless a province indicates otherwise. So I have a table here on the right to show you the different design loads, different provinces. So always check what is the design load requirement in your province. So the third step is going to be select a bedding and determine the bedding factor. So the bedding factor as a definition is the ratio of the moment induced in a section of pipe during the 3H bearing test to the moment induced in a section of a pipe when installed on the field. So the bedding factor is a very interesting concept because it's going to be the numerical representation of the width and quality of contact between the bedding and the pipe, as well as the compaction effort. So depending on how you prepare your bedding, you will have a different bedding factor. So here on the right, I have two traditional beddings. Class B, where you have your bedding up to the spring line, and Class C, when your bedding goes up to a third. And depending on how the pipe is installed, either on a trench or in an embankment, you will have different bedding factors, as you can see here on the table. shows you the importance of knowing how the pipe will be installed. But also, some provinces in Canada follow the standard installation. These ones are included in the Canadian Highway Bridge Design Code. So the standard installations will be like a B-bedding with a structural embedment up to the spring line. You can see here on the picture on the left, but you will have 4 different types. So the difference between them is that as you go down on types, you are reducing the compaction effort as well as the quality of the bedding material. This will result in a different bedding factor for each of the types of installation. So type 1 is going to be the best bedding material with the highest compaction effort, and type 4 is going to be the lowest quality of bedding material with less compaction effort. So remember to check your province's installation requirements. So the 4th step is going to be your factor of safety. So the factor of safety comes from the results of the 3H bearing test. So when a producer manufactures a reinforced concrete pipe as per ASTM or CSA standard, they need to meet the requirements of the standard as well as pass the 3H bearing test. So if you have never been on Aprica's manufacturing plant, I recommend you to watch our technical video called pipe testing. So this video will show you how the 3H bearing test is performed. So I'm just going to explain it here very briefly. So basically in the 3H bearing test, we're going to have our pipe. We're going to apply load to the top of the pipe, and we're going to have 2 beddings at the bottom, like you can see here on the picture on the right. So you are going to apply this load until you see a 0.3 millimeter crack or a hairline crack. At that point, you have reached your design load. So as you can see here on the table, that's going to be your D.3. And if you keep applying load to your pipe and the pipe fails, you reach your ultimate strength load, or the D ultimate shown on the table. So for example, for an ASTM class 2, you're going to need 50 Newton per meter length per millimeter of diameter to see that hairline crack or design crack. And you're going to need 75 to break it. So as you can see, the equation for the factor of safety is going to be your ultimate load dividing your design load. So these are going to be the default factor of safety as per the standards, either CSA or ASTM. So the 5th and final step is determining the pipe strength needed for your project. And we have all the variables that we need for it. So as you can see here on the equation, we know the loads, we know the factor of safety, the bedding factor, and the diameter. But something that I always like to point out to people is that in the equation, the bedding factor is dividing your loads, which means it will reduce your loads. The higher quality of a bedding will lower your strength class of application of pipe needed for your project. So instead of needing a class 4 for your project, probably a class 3 will be enough. If your bedding factor is good, that means you have a good installation. So now that we finished with the explanation, we can go ahead and see how the software works. So I will do 2 examples with the same parameters but different installation types. So we're going to have example number 1. It's going to be a trench installation, and example number 2 is going to be a positive projection or embankment installation. So here is example number 1. So we're going to have a 900 circular pipe that is going to be installed a 2.3 meter wide trench with a 3 meter of cover on top of the pipe. So the cover is always going to be measured to the top of the pipe. And the pipe will be backfilled with sand and gravel, having a density of 2100 kilograms per cubic meter. So the way to access the software is basically you just go to your browser and you type PipePac.com. And that's it. You're not going to be required to install anything on your computer. This is a free web-based software, and it's free thank you to all the associations that you can see on the screen. So I have a direct link here on my presentation, but if you guys just go to your browser and type PipePac.com, you basically just access the software. Just gonna click here to open my browser, And we are going ahead with our example number 1. So when you type PipePac.com, this is going to be open. This is going to be your main window. And something that I always like to show people is that if you click here, help on the top, you are going to be able to download the user manual. So you're going to click here. The user manual is going to be a PDF file that is going to show you all the inputs that are in the software. So just go ahead and click and download it and have it handy for you for your next design. So I'm just going to go back to home and we can start with example number 1. So we're just going to click here in proceed to PipePac application. And now we have 2 options. So we can create a new project or you can load an existing project. So if you used PipePac before, then you just choose your file and load your project, but we haven't done that. So you're going to start from scratch. You're just going to create a project. So here you are going to input all the information relating to your project. So in this case, it's just going to be example 1. And it's asking you for your pipe location. So it's going to go, say, Canada. The contract number 1, consultant A, contractor B, and whoever analyze basically use the software to analyze it. And then you'll click to continue. And then this window will appear and 3 parts of the software are shown. So the part of the software that I will show you is the design part, which is the 3H bearing analysis. So we're going to click here and this little window appears. So the first thing that you need to know is to name your alternative. And that is because you can create different alternatives under the same project. So we're just going to go ahead and name it option 1. You select your units, either metric or imperial. So it's going to select metric. And for the standard, you can select CSA or ASTM. So I am actually located on the west, so I'm going to select ASTM. That's what we use. I'm going to click continue. And here is our main window. So our main window has 4 tabs: pipe information, load, installation, factor of safety, and results. We're going to start here on pipe information. So the software works left to right and up and down. So we're going to start here on the pipe shape. I know I have a circular pipe. I'm going to click here. And now I can input my diameter. So if I click here on the little arrow, I get a list of standard pipe sizes. So these ones are the ones that are in ASTM C76 if it's reinforced, or C14 if it's non-reinforced. In the case of CSA, it will be A257.1 for non-reinforced and 0.2 for reinforced. So I'm just going to go down to 900 and I'm going to click there. So now I have my diameter. So span and rise, you will use them if you're designing an elliptical pipe, but in my example, I just have a circular pipe. So I'm just going to leave them as they are. Next is my pipe type. So I'm going to have a reinforced concrete pipe. And lastly, my wall thickness. So this wall thickness is going to be a standardized wall thickness. A wall is going to be your smallest thickness and C wall is going to be your largest thickness. So I recommend you to contact your local pipe producers to know what wall thickness they use depending on their equipment forms. So here for the example, I'm just going to use B wall. And then we finish with this tab. We can move to the right to load installation. So right here, we are going to input the majority of our project specific. It's going to be our dead load, our live load, how the pipe is going to be installed. We're going to input it right here. So I'm going to start with my dead load. So you're going to asking me about my soil type, so my backfill. So I know I have a sand and gravel. So what I do is that I click this little arrow here, and I'm going to see a list of soil types and their maximum and minimum soil densities. So I'm just going to scroll down until I see my gravel sand, and I click on it. So then that is going to input the density right here. But I know that my density is 2100, so software actually lets me change this value to whatever density I have. So this is very good, just in case the density is different to the defaults of the software. I have now the vertical torture loads or extra loads. We are not going to have any loads, so I'm just going to leave them at 0. And lastly, my fluid load. So my fluid load is going to be the weight of the fluid inside of the pipe. So this is not going to be very representative for a small diameter because the fluid load is going to be about the same in magnitude that the weight of the pipe, but it's going to be very representative on a large diameter. So make sure you always click yes right here. So now we can move to our live load part. So here we have different options. We have AASHTO, if you're doing a job in the States. You have Cooper for a railroad design using ARIMA loading. We have aircraft if you have an airport design. We have the Canadian Highway Bridge Design Code for track loads, CLW. You also have other for a customized loading and none if you have no live load. So I'm just going to go ahead and click the Canadian Highway Bridge Design Code and this window will appear. So here I'm going to have different options for track loads. So if you click right here, we have the regular CL625, which is used a lot across Canada. Ontario has its own 625 and Alberta load, which is CL800. So I'm just going to choose 625 since it's the one that is used more across Canada. And you can see as I select my track load, then all these windows get populated with the information for the CL625 track load. The default for the live load distribution factor is the one that you will find in the Canadian Highway Bridge Design Code section 6.9.6. So you leave it at 1.75, but you can change it like you did with the density of the soil. And also we have some default impact factors. These ones are the same that you'll see in the Canadian Highway Bridge Design Code, section 3.8.4.5.2. But if you don't want these ones, you just click yes and you can modify them. But I won't do this here for this example, so I just gonna click close and we're done with our live load. So now that we finished with our column of the left, we can move to the column of the middle. So this is going to be my height of field. So we're going to tell our software what is the depth of bury basically. So the height of field is going to be measured between the final grade and the top of the pipe. So now it's going to be buried in a 3 meter depth. So I'm just going to go ahead and change this value to 3. But I have the option to analyze the load in incremental fields or layers. So this is what these 3 little tabs mean. So here basically what it says is that my first layer is going to be at 30 centimeters and the software is going to analyze it in incremental fields of 30 centimeters until it reaches 6 meters. So since my depth of bury is 3 meters, I'm just going to change this value to 4 to reduce the size of the tables at the end. So I will show you guys that after. So now we move to the bottom, which is the installation type. I know I'm going to install my pipe in a trench installation, so I'm just going to go ahead and click trench, and this new window will appear. So the first thing is the trench width. So my trench is actually 2.3 meters, so as you can see, I'm able to change the value, so the software is very flexible with that. And my next question is my soil type. So this soil type is going to be my properties for my native soil. Because remember that I showed you guys at the beginning that the native material will have some effect in the loading. So I need to include the soil type properties in my design. So if you don't have this information in your geotechnical report, so you're basically just gonna go and look for your Rankine active lateral pressure and your coefficient of friction in your geotechnical report. But if you don't have one, the software will give you just typical values. So if I click here on the arrow, you can see that on the table. So here I'm just going to say that my native material is an ordinary clay. So here is going to be my value for it. So you are also required to enter parameters below just in case the trench exceeds the transition width. So that means that just in case my native material is not close enough to my pipe to create the frictional forces, then the software will analyze it differently. So the software needs all these extra inputs. So the first one is the projection ratio. So the projection ratio is the vertical distance between the top of the pipe and the natural ground surface divided by the outside diameter of the pipe. So generally, the preparation of a beddings by contractors results in a projection ratio of values between 0.7 and 0.9. So I'm just going to go ahead and change this one to 0.7 to be conservative. The next one is the soil lateral pressure ratio, which is another name for the Rankine active pressure coefficient. So with many interactions with SPIDA, we found that a value of 0.33, which is the default right here, has been established to be a reasonable estimate. So I'm just going to leave it as 0.32. The next one is the lateral pressure fraction, which is the indicator of the quality of compaction effort. So it is usually default to the projection ratio, so I'm just going to change it to 0.7. But if the site conditions are such that it's going to be really hard to achieve a good compaction effort, then in this case, this will be your chance to lower this value. So the next thing is the settlement ratio. So the settlement ratio is the difference between how much the soil adjacent to the pipe settles versus the soil above the pipe. So again, the software is going to give you some typical values depending on your type of soil. So you have here geol soil, ordinary soil, rock, and geoline soil. So I'm just going to select just ordinary soil. And lastly, the soil property for in this case is going to be my backfill. So at the top, there were the properties of my native material. Here is going to be my backfill. So I know I have a sand and gravel, so I'm just going to go ahead and look for it. And there you go. But if you have these values in your geotechnical report, just feel free to change them. The software lets you change them all. So we finished with all of these parameters, so we can click close. There you go. We finished with the column and the middle. So now lastly is the bedding type. So in the bedding type, I'm going to select the standard installation. So that's 1, 2, 3, and 4. But also I'm going to select the traditional beddings, which are B and C. And that is so at the end we can compare them, the results that the software gives us. So you don't have to worry about the extra information right here because these inputs are the ones for jack or tunnel applications. So we finish now with the load installation tab and we can move to the factor of safety. So as you can see right here, the defaults are ASTM C76. So they're the same defaults that I show you on the table when I was doing the explanation to you guys. So we're just going to leave them as they are because those are the defaults for the standard. So we're going to leave them there and just going to click on results. So here in results, I always like to double check that I have the correct depth of bury. So you have 2 meters, that's good. So you're going to click analyze. So the results that the software gives you will be based on the type of installation that you choose. So for each installation, you will have a certain pipe strength requirement or deload requirement. So for example, for a type 2, I need a class 2. And also, if you see this little arrow right here, you can click right here and actually see the entire analysis. So I'll see for a 3 meter depth, I need a class 2. Sometimes this is kind of tricky to read depending on how big your screen is. So you have the option to click right here in Preview Analysis and a new window will appear. So here you have your results. So this is your project description. So this is all the information that I've put at the beginning. And also you'll have all your extra data, such as your type data, your installation conditions, where were the additional loads or live load, and also the factor of safety used. And then you will see all the tables with the results for each of the type of installations you selected on the software. We have type 2, type 3, type 4, and we're going to have as well B and C. So I'm just going to take this type 2 table to show you the results. So for a 3-meter depth, I'm going to need a class 2. So the software is always going to highlight each time that you will change your strength classification. So remember I showed you that the software will have increment layers of 30 centimeters going down until 6 meters. So as you can see, it only goes up to 4 because I changed that value. So then my table doesn't get too long. And maybe I don't need that analysis, but until 4 meters is good. And also here, as you can see, only for 2.7 meters, I only need a class 1. For 3 meters, I need a class 2. So sometimes when you have a big run, you're not going to have exactly 3 meters. So it's always good to see if you have less of a field or more of a field if your classification changes. Also, right here we have a column that is called a transition width, and it's saying yes. That means that my native material wasn't close enough to my pipe to create the trench installation. So the software actually analyzes it as an embankment installation. This is what this column means. And here at the bottom, you'll see your fluid load included in the calculation. So you'll have all of these tables. So basically what you do here, just go right click and print. And then you can just print it as a PDF and just save it on your project file as a way to show that you actually did the structural design for your pipe. So I'm not going to do that. So I'm just going to go ahead and close these. And we also have another option right here, which is the preview summary. So I'm just going to go ahead and click there. And now the summary appears. So in the summary, I'm going to have the same information at the top. So the project description and all your data. Right here, your pipe data, installation condition, additional loads, and factor of safety. But the summary you will have the opportunity to compare the results in all the different types of installations that you chose. So you see here I chose all the standard installations plus the traditional bedding. So here is what you will see. Okay, if I choose a type 2, then I'll need a class 2. If I choose a type 3, I need a class D. So then you will see all that. But also you see how I got confused and I actually was talking about 3.3. And that is because the software will always highlight my depth of field, but they have these 30 centimeters as a factor of safety for error. So that's why it's showing me 3.3. So don't get scared if the software doesn't highlight the actual depth that you put on. In this case, it will be 3 meters. That's how I will see my results. So now you can compare them and you'll know if it's very easy to achieve a type 2 or type 3, then you can select your strength classification of pipe. And then again, you just go right click and print. It's going to go ahead and close that. And this is going to be basically the end of example number 1. So you have the option to save your project. So if you go here and click save, a little window will appear here at the bottom. And this is basically as if you download something. So it's just going to go to your default download folder. So in my case, it's gonna go to my desktop, but whatever default you have for your downloads, it will go there. So there is where you're going to find your job if you wanna load it again when you use PipePac. So because we finished the example, so now we can go to example number 2, which is going to have the same parameters, but it's going to be a positive projection. So basically, we have two options right here. You can either just type pipepac.com again and start from scratch, or you can create a new alternative. So this is why it's so important to always name your alternative. So in this case, I can just go ahead and go and write option number 2. We finished with option number 1. And here for my example number 2, I'm going to select metric and ASTM, and I'm going to click continue. So as you can see here, we started again in the first tab, which is pipe information. So now, because I explained it to you, everything in the example number 1, we're going to be able to do example number 2 really fast. So it's going to be a circular pipe, a 900 millimeter diameter, reinforced concrete pipe, and B-wall. So we're done with pipe information. We'll go to load installation. Soil type, we have a gravelly sand. Just go down and find it. We change it to 2100, no extra load, and yes, fluid load. Canadian Highway Bridge Design Code. The design track is going to be 625, populates it, and then we click close. My height of fill is 3 meters, and remember I changed it here to 4 meters, so my telepoles don't get too big. But now my installation type is going to be a positive projection. So these are going to be all the inputs that I showed you before. So the projection ratio, the soil lateral pressure, and the lateral pressure fraction default the same with the projection ratio. My settlement ratio, we changed this one to an ordinary soil, which is the default, but we didn't need to change it. And my soil type again is the sand and gravel. So that's the only one that I changed, and just click close. So we finish here. Now we go to our bedding type 1, type 2, type 3, and type 4, and traditional bedding B and C. So we finish with load installation. We can move now to factor of safety. We leave the defaults as ASTM C76. We click on results. I check my depth of error is correct, and then I click analyze. So you guys can see, because we did the example number 1, it was really fast and easy to do example number 2. And the results right here are going to be the same ones as example number 1, because even though I told the software that I was going to install my pipe in a trench condition, my trench width was too wide, so we didn't create that condition, and the software analyzed it as embankment installation. So this is very important to keep in mind, just in case you are not sure your contractor is going to reach the right trench. So then maybe you are just installing it in embankment condition, and that's why it's more conservative to design it with an embankment condition. So there is one last thing. Well, this is the end of example number 2 as well, but it's one last thing I want to show you. So I want to show you, for example, what it means to have a class 2 or a type 2. So what I'm going to do here is I just want to go back to my presentation, and I'm going to show you what it means. So now we know we have a 900 millimeters. I'm going to install it in a type 2 standard installation, and PipePac is telling me that it's going to be a class 2. So this class 2 actually translates to some requirements as per the standard. So as per ASTM C76, this is what it means. So just basically just gonna go to table number 2. And the first thing that you notice is going to be my D loads. So the loads that are found in the 3H bearing test. So we have our 50 Newton per meter length per millimeter to create my design crack, and 75 to failure. So now, for my example, we chose a B-wall. So that will give us a concrete strength of minimum 27.6 MPa. And for a 900 millimeters, we will have a certain reinforcement the pipe. So something that I want to clarify right here is that the elliptical cage that you see here is a substitute for the two cages, so the inner and the outer cage. So it doesn't mean that on site you're going to have all the cages, so you either have the outer cage and the inner cage or the elliptical cage. So this is what this reinforcement means right here. And that basically concludes my explanation. So if you like this video, please click like and don't forget to follow us in other social media platforms. So follow us on LinkedIn under Canadian Concrete Pipe and Precast Association. You can like us on Facebook with the same name. You can follow us on Twitter at CCPPA Concpipe. And of course, don't forget to subscribe to our channel, Canadian Concrete Pipe and Precast Association. So that's it for today. Thank you for watching.